Today we are going to learn about the domain and the range of a quadratic graph. Now, first of all, it's no different than what we learned earlier this year when we had a linear graph. Remember, a linear graph made a line, a quadratic graph makes a U. So with that, the domain and the range actually I think is a little bit easier of this graph than it is of the graph we did earlier in this year. So first of all, we need to review what the domain is. If you recall, the domain is the what? Awesome. It's the x values of my graph. Then what was my range? Excellent. It is the y values of my graph. So with that, that's never changed. That's never, ever going to change, okay, with what we are doing. When you get up into Algebra 2, things get a little wonky, but right now that's never going to change. What does change is looking at my graph. So here I've got my coordinates. Here's an x and here's the y-axis. So then I have this graph that's going to be like a U. So with that, what would be the domain of this graph? Well, we know the domain is this x-axis, and it's whatever's covered in this x-axis with my graph. Well, because my graph has these two arrows always on it, it's going to go on and on forever up. So no matter what, whatever we are doing with our quadratics in Algebra 1, the domain is always all real numbers. And we see it as written as the set of all real numbers in words, or you might see the big R for real numbers, the set of real numbers. And then sometimes, they put the set of x such that it's the set of reals. So it looks different, but it's all real numbers. It's always the real numbers. That never, ever, ever changes. So any question that asks you what the domain of your quadratic graph is, the answer is all real numbers. So how does the range become wonky? The range becomes wonky because the range does have a set value. The range is everything inside of my graph. So it's from my vertex point here up forever. So it's always going to be an inequality to whatever the y value is in my vertex here. So when I write my range is always going to be the set of y such that y is going to either be greater than or less than or equal to whichever one it is. So here it's everything greater, so it's going to be greater than or equal to, and whatever then, this is the y of my vertex. I'm going to show you some examples of that in a second. We're going to show some examples of that in a second, but that's all domain and ranges. It has never changed from what we did earlier, okay? Just looks a little bit different. Domain, never get wrong. Range, just think about what your graph is doing, whether it's going up or down. That's all this is, whether he's going up or down, y of my vertex, no matter what. So let's look at some examples. So, first of all, looking at number 1. So we're going to do the domain first. So looking here at the domain, I have my arrows. He goes on forever, covering my x forever and ever and ever. So my domain, my domain is always the set of all real numbers. Always. Okay, so now when I look at my range comes from this point right here, and it goes down forever. Well, what's that point right there? The y value is the 4. It's right there. So my range is, sometimes they write it as the set of y. It just depends if they write that or not. But this is the second part that's important. It's the y. He's everything less than or equal to that number 4. He's less than or equal to that number 4. And that's all you got to know. Simple as pie. All right, so let's look at number 2 for our domain. Arrows go on forever, means he's going to spread out and spread out and spread out. So he's all of that x-axis forever and ever and ever. So our domain is all real numbers. Now the harder part's the range. So my range goes down from here. My y value is 4. So my range is the set of y such that y is less than or equal to 4 again. Just happens to be 4 again. All right. So who can tell me what the domain of number 3 is? Exactly. Domain's all real numbers. Remember, we said the domain's always all real numbers. Because he's got these things that go on forever, he's going to cover this x-axis forever. So he's always all real numbers. So now we're looking at the range. Okay, this time he's going up from this point here. This point from my y is right there. So my range is the set of y such that y is exactly greater than or equal to -4. Let's do 1 or 2 more just to make sure we're on the same thing. So go ahead and write the domain and range for me for number 4 while I write it as well. So first the domain. Excellent. The domain is all real numbers. Now my range. Excellent. And let's just do one more for safe measures. Give me the domain and the range. All right, check your work when you're done. Excellent. Excellent. Have a great day and thank you for spending some time with me.